Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. So this is the new chapter, the next chapter, linear equations. This is part 1 video on the chapter of linear equations, where I will discuss about already the concepts that you have studied in your previous class, that is class 7. That is, I will give a preview of previous class and the concepts of what is a linear equation, forms of an equation and rules to solve linear equations, and finally we'll solve some selected problems of exercise 8A from the textbook of author RS Aggarwal. So this video is part of the playlist CBSE Maths for class 8 following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos on regular basis and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with this video. Okay, so I have the canvas on the right hand side, where I will discuss the concepts and we'll solve the problems from exercise 8A of the textbook of author RS Aggarwal. I hope the fonts are big enough on the canvas that I have written, and it is properly readable. Okay, so let's start. So this video I will give a preview of the concepts that you have already studied in your previous class. So let's start from some basics. Now, to understand what is a linear equation, we need to understand what is a polynomial. So a polynomial is an algebraic expression where all the variables have non-negative integers as powers. Now, what is non-negative integer? Okay, so what is non-negative integers? Non-negative integers are the 0, the number 0, 1, that is the whole numbers. These numbers, that is, all the variables will have powers of either 0, 1, 2, 3, 4, like this. So let's take so for example, the algebraic expression minus 4 x to the power 3 y plus y square minus z. This is a polynomial, because this is an algebraic expression where all the variables, we have 3 variables x, y, z, and all the variables, their powers are non-negative integers. That is, either they are 0 or they are greater than positive numbers, positive integers. That is 0 or positive integers. That is, the powers are whole numbers. Now, if I add a constant, let's say plus 4, then I can say that 4 can be written as 4 multiplied by 1, and 1 is nothing but, I can say, x to the power 0 or any other variable to the power 0. So that is the reason we say that the power 0 is also included. Now, this is a valid polynomial. This is a valid polynomial, but consider this algebraic expression 2 by x, or this is not a valid polynomial, because the power of x, it is minus 2 by x. 1 by x means x to the power minus 1, and minus 1 is not a non-negative integer. So this is not a polynomial. Likewise, if you have, let's say, x square by z to the power minus 2, this is also not a polynomial, because this is an algebraic expression, but the power of z is a negative integer. So I hope it is clear what is meant by a polynomial. That is, a polynomial is an algebraic expression. It can have one or more variables, but all the powers of the variables must be non-negative integers. That is, they can be 0 or 1 or whole numbers. Expressions like, let's say, x plus 1 by x, this is also not a polynomial. This is also not a polynomial. Similarly, let's say minus 1 by root x is also not a root x, the power of x is half, which is also not a non-negative integer. So all these expressions are not 1 by root x, these are or minus x plus 1 by x, these are not polynomials. A polynomial will, all the terms of the polynomials will have variables. If they have variables, all the variables will have powers of 0 or positive integers. So that is the basic concept of a polynomial. Now, what is a linear polynomial? A linear polynomial is a polynomial of degree 1. Now, what is the degree of a polynomial? Before that, we have to understand what is the degree of a polynomial. Degree of a polynomial is, so every term, so degree of a polynomial is the maximum degree of all its terms. So let's say I have an expression, let me quickly check if everything is visible or not. Let's say I have an expression minus 4 x cube y minus x square y square plus z minus 2. Now, what will be the degree of this polynomial? This is definitely a polynomial because all the powers of the variables are 0 or positive or non-negative integers. The power of z is 1, the power of y in the second term is square, is 2, and the power of x in the first term is 3, and the power of x in the second term is 2. So all the powers are non-negative integers. Now, what is the degree of this polynomial? The degree of this polynomial is the maximum degree of its terms. Now, so first you have to understand what is meant by a degree of a term. What is the degree of the first term? Let's say, okay. So let's say what is the degree of the term minus 4 x cube y. Degree of a term is the sum of the powers of all its variables. So in the term minus 4 x cube y, the variables are, the variable part is x cube y, and the sum of their powers is 3 plus 1 equals to 4. So the degree of the first term, that is minus 4 x cube y, is 4. What is the degree of the second term? The degree of the second term, that is minus x square y square, is 2 plus 2 equals to 4. And what is the degree of the term z? It is 1 because the power of z is 1. And what is the degree of the term minus 2? It is 0 because it has no variable. Any constant term, its degree is always 0. So what is the maximum degree? We have two maximum degrees, 4, 4. So the degree of this polynomial is 4, because we are having two terms having the maximum degree, that is 4. So the degree of a polynomial is the maximum degree of all its terms. Now come back to linear polynomial. So a linear polynomial is a polynomial of degree 1. Examples are minus 4x plus y, or minus 2x plus 1. These are all a linear polynomial, because you see in any term, so the degree of all these polynomials is 1. But is this minus 9? Is this is obviously a polynomial, because it has only one term, minus 9, and it is a constant term, and as I said, a constant term has a degree 0. So this is definitely a polynomial. But is this a linear polynomial? No. Because why? Because the degree of the polynomial minus 9 is 0, but a linear polynomial will have a degree 1. So the first two polynomials, minus 4x plus y, their degree are 1, because you can see in the expression minus 4x plus y, the first term minus 4x, the degree is 1 because the power of x is 1. Also the second term, the degree is 1. So both the terms are having degree 1, and hence the maximum degree of the terms is 1. For the second expression also, minus 2x plus 1, the degree of the first term minus 2x is 1, but the degree of the second term 1 is 0. But the maximum, hence the maximum degree of the two terms is 1, and hence the degree of the polynomial minus 2x plus 1 is 1. Other examples could be, let's say, x plus y plus z. So the x plus y plus z is also a polynomial of degree 1, because as you can see, all the terms are having degree 1. But these polynomials, this polynomial x plus y plus z has 3 variables. The first, the polynomial minus 4x plus y, it has 2 variables. So it is a linear polynomial in 2 variables. The polynomial minus 2x plus 1, it has only 1 variable, x. So it is a linear polynomial in 1 variable. X plus y plus z is also a linear polynomial in 3 variables, because we have x, y, z. Okay, so we understood what is a linear polynomial. Now, what is a linear polynomial in 1 variable? It must be very obvious that a linear polynomial in 1 variable is just a linear polynomial where all terms have a single variable. That is, the entire polynomial will involve only a single variable, like minus x plus 1 minus 4x plus 1 by 4. This is also a linear polynomial in 1 variable. These are all linear polynomial in 1 variable. But minus x plus y, this is not a linear polynomial in 1 variable, because we are having 2 variables. So this is not a linear polynomial in 1 variable. So let's say z minus 2, this is also a linear polynomial in 1 variable, where the variable is z. Hence let's say t, let's say 3t by 2 minus 4, this is also a linear polynomial in 1 variable, where the variable is t. So I hope it is clear what is a linear polynomial in 1 variable. Now let's come to the definition of what is a linear equation in 1 variable. In class 8, you will only learn linear equation in 1 variable. So what is a linear equation in 1 variable? Okay. Before understanding what is a linear equation in 1 variable, you have to understand what is a equation. What is an equation? Let's say, okay, let me first move this down. Let's first understand what is an equation. I hope my reading is readable. I'm using a very different software and really not having a good control of the pen. Anyway, I'm trying my best. What is an equation? What is an equation? An equation is basically a statement of equality of two algebraic expressions. Like let's say, let E1 and E2 are two algebraic expressions. E1 and E2 are two algebraic expressions. Then statement of equality is nothing but you have this equality sign, and on the right hand side you will have some algebraic expression, let's say E2, and on the left hand side you will have another algebraic expression, let's say E1. Then this is an equation, and we say that E1 equals to E2, that is where E1 and E2 are some algebraic expressions. So let's say so it can be like 4x square equals to, let's say, x plus 1. So we can see that 4x square is an algebraic expression. Also x plus 1 is also an algebraic expression. So 4x square equals to x plus 1 is an equation. So another example can be, let's say, minus x by 2 minus 1 is equal to let's say 4x plus 2. So this is also an equation where 4x plus 2 is an algebraic expression, and minus x by 2 minus 1 is also an algebraic expression. Now, by convention, the expression to the right hand side of the equality sign, we call it, we name it, by convention, we say it is the RHS, that is the right hand side of the right hand side. That is, when we say RHS, we mean the expression to the right hand side of the equality sign. Also, the expression to the left hand side of the equality sign, we call it by convention LHS, that is left hand side. So for the first equation, for this equation, the LHS is 4x square and the RHS is x plus 1. For this equation, the LHS is minus x by 2 minus 1 and the RHS is 4x plus 2. So this is an equation. This is an equation where we have equality sign, and on both sides of the equality signs we have some algebraic expressions. Okay. So this is the definition of, in general, the definition of an equation. Now, what is a linear equation in one variable? Linear equation in one variable. So definitely we will have kind of a statement of equality, that is, there will be an equality sign, and on the left hand side there will be something, some expression, and on the left and on the right hand side there will be so on the left hand side the LHS. So this is the LHS. LHS, we will have some algebraic expression, and on the right hand side also we will have some algebraic expression, and that is the RHS. Now, what is the what kind of algebraic expression will be on both sides of the equality sign? That will primarily differentiate a linear equation in one variable from a equation in general. Now, this expression, you can say this expression, let's say I'm calling it, let's say linear, actually it must be a linear polynomial. The expression on both the sides must be a linear polynomial. Let me call it a linear polynomial by LP. So let's say on the right hand side we have LP2, and on the left hand side we have LP1. So LP1 and LP2 are linear polynomials in one variable, because since we are having a linear equation in one variable, hence both the polynomial on the either side of the equality sign must be linear and in one variable. So LP1 and LP2 are linear polynomials in one variables. So an equation, if an equation where both the LHS and RHS are a linear polynomial in a single variable, then that kind of equation is known as a linear equation in one variable. Now, the examples are like x minus 1 equals to 2. This is an example where the left hand side LHS is the linear polynomial. Now, okay. I think now I would like to redefine the definition. I said that both the sides, the algebraic expression on both the side of the equality sign, that is both the LHS and RHS must be linear polynomial in one variable. But it is not like that. At least one of them must be a linear polynomial in one variable. That is, either any one of them can be also just a constant, that is a number, and we have just discussed that just a number, that is minus 9, is not a linear polynomial, because a linear polynomial will definitely must have a variable, at least one variable where the power is 1. So in a linear equation in one variable, at least one of LP1 or LP2 has to be a linear polynomial in one variable. They both can be linear polynomial in one variable, or at least one of them has to be a linear polynomial in one variable. If one, so the other one can be a constant. For example, x minus 1 equals to 2, the RHS is not a linear polynomial in one variable, it is a constant. The LHS is a linear polynomial in one variable, that is x minus 1. 4x, another example is 4x plus 3 is equal to minus 5x minus 9. This is a linear equation in one variable where both the LHS and RHS are linear polynomial in one variable. It could be like 3 equals to 4x by 9, where in this example the RHS is a linear polynomial in one variable, but the LHS is a constant, number. Okay, so these are some examples of a linear equation in one variable. Okay, so one other examples could be x plus 1 by 2 equals to 4x by 3 minus 2. So this is also a linear equation in one variable where both the LHS and RHS are linear polynomial in one variable. X plus 1 by 2, it is a linear polynomial in one variable, and 4x by 3 minus 2, this is also a linear polynomial in one variable. Hence, this equation is a linear equation in one variable where both the LHS and RHS are some linear polynomial in the same variable. Okay. Now, some other complex examples of a linear equation in one variable is like this: x plus 1 divided by 2x plus 1 equals to, let's say, 1 by 2. Now, this x plus 1 by 2x plus 1 equals to half. This actually may not look like a may not look like a linear equation, but this can be reduced. This can be reduced to a linear equation in one variable by applying some rules. We will study a little later on. We will study very shortly what are the rules to solve a linear equation. So applying one of that rule, this equation, that is x plus 1 by 2x plus 1 is equal to half, can be reduced to a linear equation. I hope it is clear what is a linear equation in one variable. So it is a statement of equality where both the sides, both the LHS and RHS, either both the LHS and RHS are linear polynomial in one variable, or one of them is a linear polynomial in one variable and the other one is a constant. So at least one of them has to be a linear polynomial in one variable. So this is a linear equation in one variable. Okay, now let's understand what are the forms of linear equation. So we have understood what is a linear equation in one variable. That is, it is a statement of equality where at least either the LHS or RHS of the equality sign has to be a linear polynomial in one variable. Now there are some forms of linear equations. Let's try to understand that. The first one is the simple linear equations. Now in a simple once again, friend, someone is at the door. I'm sorry, friends. Sorry for the delay. There was someone at the door. Okay. So, where was I? Okay. So, let's understand what are the various forms of linear equations. So, first one is the simple linear equations. Now, in simple linear equations, we have uh, linear polynomials. Either it can be either the LHS or RHS is a linear polynomial in one variable. So this is x plus 2 is equal to 4. So this is a form of simple linear equations where the variable is on the left hand side. That is, the LHS is a linear polynomial in one variable and the right hand side is a constant. If it is the other way around, let's say minus 9 is equal to 3x by 2. Let's say 3x plus 1 by 2. Then this is also a no. This is not a This is not a simple linear equation. Let's say we have plus 1. So this is also a simple linear equations where the variable is on the right hand side. That is, the RHS is a linear polynomial in one variable and the LHS is a constant. So in the first case, the LHS, the variable was in the LHS. In the second example, the variable is in the RHS, and the variable could be on both sides. That is, both LHS and RHS could be a linear polynomial in one variable. Let's say minus 2x minus 1 is equal to minus 3x plus 5. In this example, both the variables is occurring on the LHS and RHS. So this is another simple linear equations. So we have basically three types of simple linear equations. First one is where the variable is on the left hand side, the right hand side is purely a number, a constant. The second one is that the variable is on the right hand side and the left hand side we have a constant number. And the third one is we have variables as well as constants on both the sides. So this was some examples of simple linear equations. Now, what is linear equations reducible to simple form? These are linear equations which are not very simple, but they can be reduced to a simple form. Examples are minus 3x by 2 plus 1 is equal to x by 6 plus 2. Now, as you can see, why it is we are having variables on both the sides, but we are having some rational form. Minus 3x by 2, it is a kind of rational form. X by 6, it is a kind of rational form. Just because of the presence of some rational terms, we say we do not consider this kind of linear equations in the simple form. We say, but we can easily convert by doing some manipulation. We can easily convert these linear equations to simple form, and the method we apply is that if we take the LCM of the denominators of all the rational terms. Now, in this example, in these examples, we have the minus 3x by 2 is the rational term and x by 6 is the rational term, and we see that 2 and 6 are the denominators. So we take the LCM of 2 and 6. If the equation has as many rational terms are there in the equation, we will find the LCM of all their denominators. So LCM of 2 and 6 is 6, and we multiply both the sides by 6. That is, we multiply both LHS and RHS by 6, and we get 6 multiplied by minus 3x by 2 plus 1 equals to 6 multiplied by x by 6 plus 2. Now, if we do the product, if you do the product on both sides and simplify, you will get this will become minus 9x plus 6 is equal to x plus 12. Now you see the rational terms are gone. We are having simple form. So this kind of equation, minus 3x by 2 plus 1 is equal to x plus x by 6 plus 2, where we have some rational terms, is not considered as a simple form, but it can be reduced to a simple form by doing by doing some manipulation, which is multiplying both the sides by the LCM of the denominators of all the rational terms. So another example of linear equations is reducible to simple form can be like x plus 1 by 2 is minus x by 4 is equal to 3x by 2 minus 3. As you can see, there are some three rational terms. The three rational terms are x plus 1 by 2 and minus x by 4 and 3x by 2. Because of these rational terms, it is not considered as a simple form, but we can reduce this equation to simple form by multiplying both the sides by the LCM of 2, 4 and 2, which is 4. So if you multiply both the sides by 4, it will be reduced to simple form. So this was linear equations reducible to simple form. Now another one is equations reducible to linear form. Now these linear equations reducible to simple form, these equations minus 3x by 2 plus 1 is equal to 6x by 6 plus 1 was a linear equation, but there can be some equation which may not look which is not actually a linear equation. For example, x plus 1 divided by x minus 2 is equal to 3. The left hand side, x plus 1 divided by x minus 2, this is not a linear polynomial. This is not a linear polynomial, and hence this entire equation is not considered to be in the linear form. But if you do some manipulation, that is by applying the rules of solving a linear equation, which we will discuss a little shortly, we can convert this equation to linear form. So this is an example of an equation which can be reduced to a linear form, but in this current form, it is not a linear equation, because the polynomial, that is LHS x plus 1 divided by x minus 2, this is not a linear polynomial. Another example could be x plus 1 by 3x is equal to x by 3x minus 2. This is also this equation is also not in linear form, because both LHS and RHS, they are not a linear polynomial. They are not linear polynomial. In fact, they are not polynomial at all. X plus 1 but divided by 3x is not a polynomial. Similarly, x by 3x minus 2 is not a polynomial, but this equation can be reduced to linear form. That is a linear equation in linear form by doing some by applying some rule, which we will study shortly. So these are kind of equations which can be reduced to a linear form. Okay, now let's study what are the rules which you have already studied in your previous class. I'm just recalling. I'm just giving you a preview of what you have already studied in your previous class. So what are the rules to solve a linear equation? The first one is that same number can be added or subtracted from both sides of the equation. Like if you have an equation minus 2x minus 2 is equal to let's say 4. So this is a linear equation. Now to solve this linear equation, I can say this. So when it says that same number can be added and subtracted from both sides of the equation, it means that if I add or subtract same number from both sides, the equality remains unchanged. That is the equality, the validity of the equation remains the same. So I can say from this equation, if I can add 2 on both sides, I can do this: minus 2x minus 2 plus 2. I am adding 2 on both sides and I get this. So this implies on the left hand side 2 and minus 2 gets cancels out and I get minus 2x equals to 6. Now from here I can say that x is equal to minus 6 by 2, that is 3. So I added from the given equation, I added 2 on the both sides. I added 2 on to both the LHS and the RHS. I can also subtract the same number from both sides. Like if I have 4x plus 1 is equal to 6, I can say that this equation will remain the same if I subtract 1 from both sides. That is 4x plus 1 minus 1 is equal to 6 minus 1. So I subtracted 1 from both the LHS and the RHS, and the equation becomes plus 1 and minus 1 cancels out, and we have 4x equals to 5, and this implies x equals to 5 by 4. So this way we can add or subtract the same number from both sides, that is from both LHS and RHS of the given equation. The second rule is that we can multiply both sides by a non-zero number, by the same non-zero number. By the same non-zero number, we can also divide both sides of the equation by the same non-zero number. Meaning, let's say if you have something like 3 by 2 x is equal to 4. If you have an equation like this, then I can multiply both sides by 2 by 3. Now, why 2 by 3? Because if I multiply both sides by 2 by 3, the LHS will become x. So I can say that this I can multiply both sides by 2 by 3. I can do this because the left hand side will then become 3 by 2 and 2 by 3 will cancel out. It will become x will become equal to, the right hand side is 4 into 2 by 3, which is 8 by 3. So this was, I multiplied 2 by 3 on both the sides. Let's say I can also divide both the sides by the same number. Let's say I have 5x equals to, let's say, 125. I'm taking very simple examples just to illustrate the concept. Now I can divide both the LHS and the RHS by, let's say, 5, and the equality will remain the same. I can do this. So this implies 5x by 5 is equal to 125 by 5, and the LHS will become x is equal to 125 by 5 is 25. So this way I can multiply by the same multiply both the sides of the linear equation by the same non-zero. It must be non-zero number. I can multiply as well as divide both sides by a non-zero number. Okay. Now comes the cross multiplication. If you have a linear equation of this form, that is the LHS is equal to, is of the form ax plus b, where AB here a, b, c, d, p and q are constants. If you have the LHS as ax plus b divided by cx plus d, and the right hand side is p by q, then you can cross multiply this way. That is, you will multiply q with ax plus b and you will multiply p with cx plus d, and those products will be equal. That is, we will have q multiplied by ax plus b will be equal to p multiplied by cx plus d. This is known as cross multiplication. Once you do cross multiplication, as you can see, this form is a simple form. This is a linear equation in simple form, whereas this equation, that is ax plus b divided by cx plus d is equal to p by q, this is not a linear equation. This is not in the a linear equation. uh, because the LHS is not a linear polynomial. It is not a linear polynomial. But after doing cross multiplication, you can see that it is being reduced to the linear form. So applying cross multiplication, some equations which may not be in the linear form can be reduced to a linear form. Okay. The next one is any term can be transposed to other side of the equation with a change in its sign. This is super important. This one you will be always using in solving linear equations. Now what does it mean? Let's say we have an equation like minus 4x minus 2 is equal to 5x 5x let's say minus plus let's say 16. Let's say you have an equation like this. Now it is saying that any term can be transposed to other side of the equation with a change in its side. It means that if you transpose means shifting, moving a term from either LHS to RHS or a term from RHS to LHS. Now consider if I move let's say this term, that is the minus 2, from the LHS to the RHS. I will move this to RHS, and I will move the term 5x from the RHS to LHS. What will the equation look like? When I am moving, so I am not moving the terms minus 4x and plus 16. So they will remain as it is. They will remain as it is. Only the I am transposing the term minus 2 from the left hand side to the right hand side. Now so on the right hand side, I will have to change the sign of the term minus 2. The sign of the term minus 2 is minus. So when it will be transposed to the right hand side, it will be 2. It will be 2. So I have 2. Also, the term 5x from the RHS was transposed to LHS, and the term 5x, its sign was positive. But when I will transpose this term 5x to the LHS, it will become minus 5x. So minus 5x. So this is the equation. It becomes after transposing minus 2 from LHS to RHS and transposing 5x from RHS to LHS, and hence the equation, if you simplify further, it becomes minus 9x is equal to 18. This implies x is equal to minus 18 by 9, that is minus 2. So this is what we know, what we call transposition of terms. So when you transpose term from one side to the other, you have to change its sign. This is the basic concept. Okay. Now let's try to solve few examples from the exercise of 8A from the textbook of author RS Aggarwal. I have selected some problems. Let's see. So this is exercise 8A. The first one is question number 4. It is 9x plus 5 is equal to 4 into x minus 2 plus 8. So this is a simple form of linear equation where both the sides are having the variables. So what we will do, first of all, we would like to do the products, that is 4 into x minus 2, and open the brackets. So this will become 4x minus 8 plus 8. So this implies 9x plus 5 is equal to minus 8 plus 8 cancels out. We have 4x. Now we will transpose all the we will do some transposition of terms so that all the variable terms, that is all the terms having the variable is on the left hand side, and all the constant terms is on the right hand side. So I will have to transpose, I will transpose 4x to the left hand side, and I will transpose 5 to the right hand side. So when I transpose 4x to the left hand side, its sign will change, it will become minus 4x. And when I transpose 5 to the right hand side, its sign will change, it will become minus 5. So I have minus 5. So this implies, now if I simplify the left hand side, that is add the like terms, I get 5x is equal to minus 5. This implies x is equal to minus 5 by 5, which is equal to minus 1. Okay, now let's do problem number 5. This is 7y by 5 equals to y minus 4. Now what is the form of this equation? This is not a simple form. This is an equation reducible to simple form, because we are having a rational term. The LHS is a rational term. There is only single rational term where the denominator is 5. So we would like to multiply both sides by 5. If you multiply both sides by 5, we get 5 multiplied by 7y by 5 is equal to 5 multiplied by y minus 4. So this implies, if you do the multiplication products on both the sides and simplify, you will get, on the LHS 5 cancels out, and we get 7y is equal to, on the right hand side we get 5y minus 20. Okay, now I will do transposition of terms. I will bring all the variable terms to the left hand side and keep all the constant terms on the right hand side. So this will become 7y minus 5y is equal to minus 20. This implies 2y is equal to minus 20. This implies y is equal to minus 20 by 2. This is equal to minus 10. Okay, let's do 6. 6 is 3x plus 2 by 3 is equal to 2x plus 1. So this is also an equation which can be reduced to simple form, because this is not a equation in simple form, because we are having a rational term 2 by 3. So what we can do is we can multiply both the sides by the denominator of the rational term, that is 3. That is, if we multiply both sides by 3, and then we do the product and simplify further, and we get the LHS becomes 9x plus 2 is equal to 6x plus 3. Okay, now this becomes a linear equation in simple form. Now we will just transpose terms so that all the variable terms comes to the left hand side and all the constant terms comes to the right hand side. So it will become 9x minus 6x is equal to 3 minus 2. So this implies, after simplifying the LHS and RHS, that is after simplifying adding the like terms on the LHS, we get 3x is equal to 1, and hence this implies x is equal to 1 by 3. Okay, let's do so while I am solving the problem, if you think it will be beneficial, you can pause the video and take screenshot. Let's do 8. 8 is 3 multiplied by 5x minus 7 minus of 2 multiplied by 9x minus 11 equal to 4 8x minus 13 minus 17. Now you can also consider this linear equation to be not in simple form, because there are some products. So we are having 3 multiplied by 5x minus 7. Because of this, you can also consider this as a linear equation reducible to simple form. Reducible to simple form because we have to ultimately do the product of the constants with the binomials. So if I do the products and open up the brackets, I get 15x minus 21 minus 18x plus 22. Now for solving linear equations in one variable, you have to be very strong in the chapter of algebraic expressions and operations, that is addition, multiplication of algebraic expressions, and multiplication and division, subtraction of algebraic expressions. That is the chapter operations on algebraic expressions. You must be very strong in that chapter. Only then you will be able to properly solve the problems of linear equations. So we have this, on the right hand side becomes 32x minus 52 and minus 17. Now I will do transposition of terms, that is I will bring all the variable terms to the left hand side and all the constant terms to the right hand side, and I get 15x minus 18x minus 32x equal to minus 52 minus 17 plus 21 minus 22. This implies, if you simplify the LHS and the RHS, the LHS becomes, if you add the like terms, 15x minus 18x is minus 3x, and here minus 35x is equal to 21 minus 22 is minus 1, and minus 17 minus 1 is minus 18, and minus 18 and minus 18 and minus 52 is minus 70. So this implies x is equal to minus 70 divided by minus 35. This is equal to 2. Okay. Let's do problem number 9. This is x minus 5 by 2 minus x minus 3 by 5 equals to half. Now this is also a linear an equation reducible to simple form. This is not a simple form because we are having rational terms. The two rational terms are x minus 5 by 2 and minus of x minus 3 by 5. These are the two rational terms. So this equation is not in linear form, not in simple form. So we can easily convert this equation to simple form by multiplying both sides by the LCM of 2 and 5. LCM of 2 and 5 is 10. So we have to multiply both sides of the equation by 10. So we get 10. The left hand side is x minus 5 by 2 minus x minus 3 by 5, and the right hand side is 10, and we have 10 multiplied by half. The right hand side is half, so we have multiplied 10 to both sides of the equation. Okay, now if you multiply 10 with if you simplify, if you do the product of 10 and the LHS and simplify, you get this becomes 5 into x minus 5 and minus 2 into x minus 3 is equal to 10 by 2 is 5. So now still this is not in a simple form, as we are having products of some binomial, that is we are having the product 5 into x minus 5 and 2 into x minus 3. But this can be reduced to simple form if you do the product and open the brackets. So this becomes 5x minus 25 minus 2x plus 6 equals to 5. Now this equation is in simple form. Okay. Now I will keep all the variable terms on the left hand side and all the constant terms to the right hand side by doing some transposition of terms. So I get 5x minus 2x is 3x, and I bring the constant from LHS to the RHS, and I have 5 plus 25 minus 6. So this implies 3x is equal to 30 minus 6 is 24. So this implies x is equal to 24 by 3, which is equal to 8. Okay. Let's do 11. The question is 2x plus 7 by 5 minus 3x plus 11 by 2 equals to 2x plus 8 by 3 minus 5. So this equation is also not in a simple form. As we can see, rational terms, 3 rational terms, this one, this one, and this one. These are 3 rational terms having the denominators 5, 2, and 3. So we have to multiply both the sides of the equation by the LCM of 5, 2, and 3, which is equal to 30. So we have to multiply both the sides of the equation by 30, because 30 is the LCM of the denominators of all the rational terms. So we multiply both sides. The LHS is 2x plus 7 by 5 minus 3x plus 11 by 2 equals to, the RHS is 2x plus 8 by 3 minus 5. Now if you do the product, do the multiply both the sides by 30. If you do the product and simplify, we get 6 multiplied by 2x plus 7 minus 15 multiplied by 3x plus 11 is equal to 10 multiplied by 2x plus 8 minus 150. So now the rational terms are gone, but still this equation is not in simple form, because we are having the products, right? 6 multiplied by 2x plus 7 minus 15 multiplied by 3x plus 11. But this can be reduced to simple form if you do the product and open up the brackets. So this becomes 12x plus 42 minus 45x minus 115 into 11, 165 equals to 20x plus 80 minus 150. Now this equation is in simple form. Now we will have to do some transposition of terms, so that all the variable terms is on the left hand side, and all the constant terms is on the right hand side. And in doing so, we get 12x minus 45x minus 20x is equal to 80 minus 150 minus 42 plus 165. Now I am prone to make mistakes. I might be doing some calculation mistakes. I'm not focusing in that. I'm just trying to please understand the concept and the methods that I'm applying to solve the problems. Now if you simplify further the LHS and the RHS, it will become, if you add up the like terms on the LHS, it will be 12x minus 12x minus 65x is equal to 165 minus 150 is 15, and 80 minus 42, so 80 minus 42 is 38 plus 15. So this implies 12x minus 65x is minus of 53x is equal to, the right hand side, 38 plus 15 is also 53. So this implies x is equal to 53 divided by minus 53. This is minus 1. Okay. Let's do, this was 11. Let's do 16. 16 is 8x minus 3 divided by 3x equals to 2. So this is of the form we discussed in the rules to solve linear equations, that applying cross multiplication, if you have an equation of the form ax plus b divided by cx plus d is equal to p by q, then you do cross multiplication, and we can see that this equation 8x minus 3 by 3x is equal to 2 is of the form, it is of the same form. So we will do 2 you can consider as 2 by 1. So we will do cross multiplication, and we get 1 multiplied by 8x minus 3 is equal to 2 multiplied by 3x. So this implies the LHS becomes 8x minus 3 is equal to, the RHS is 2 into 3x, that is 6x. Now bringing all the variable terms to the left hand side and all the constant terms to the right hand side by transposition, we get 8x minus 6x is equal to 3. This implies twice x is equal to 3. This implies x is equal to 3 by 2. I will do one more problem, that is the 28. The rest of the problems, I hope you can solve them. They are pretty similar. 28 is 2 minus 7x divided by 1 minus 5x equals to 3 plus 7x divided by 4 plus 5x. Now you can see that this equation is definitely not in the linear form, because both the LHS and the RHS are not polynomial. But this you can do cross products. If you do cross products, you will see that the whatever equation you will get, it will be in the linear form. So whenever you have this kind of equation, in the rules to solve linear equations, it only said that, it only talked about the form ax plus b divided by cx plus d is equal to p by q. Now if this is the form of the equation given, then you do cross product. Now instead of p, it can also be an expression having a very linear expression in x, and also p can be a linear expression in q. It can also be, just like in this problem we have the RHS is also an expression where it is of the rational form, where both the numerator and the denominator are a linear polynomial in x. That is 3 plus 7x, it is a linear polynomial in x, and 4 plus 5x, it is also a linear polynomial in x. But 3 plus 7x divided by 4 plus 5x, this is not a linear polynomial. This is not a polynomial. This is not even a polynomial. But if you do cross product, you will see that the equation will get reduced to linear form. So let's do the cross product, and that is you do cross multiplication. That is the if you equate the cross products, that is we will get 4 plus 5x multiplied by 2 minus 7x will be equal to 1 minus 5x multiplied by 3 plus 7x. So this is the only method we apply, that is cross multiplication, to solve this kind of equation. Even though this equation is not it does not look like a linear equation, if you do cross multiplication, you will see it will get reduced to the linear form. Now I will have to do the products on both the LHS and RHS using the distributivity law of multiplication over addition and subtraction. I get the LHS as 4 plus 5x multiplied by 2 minus 4 plus 5x multiplied by 7x is equal to, the right hand side becomes 1 minus 5x multiplied by 3 plus 1 minus 5x multiplied by 7x. So you must be very strong and clear about doing multiplication, division, addition and subtraction of algebraic expressions. Okay. So if we do further simplification, if we do the products of the monomial and the binomials on both the sides, we get 4 plus 5x into 2 becomes 8 plus 10x, and 4 plus 5x multiplied by 7x becomes 28x plus 35x square. On the right hand side, 1 minus 5x multiplied by 3 becomes 3 minus 15x, and 1 minus 5x multiplied by 7x becomes 7x minus 35x square. Now you have to open up the brackets, and you have to further simplify both the sides, both the LHS and RHS, by opening up the brackets, and we get 8 plus 10x equals to, 8 plus 10x minus 28x minus 35x square is equal to 3 minus 15x plus 7x minus 35x square. Now by doing transposition, we will bring all the variable terms to the left hand side and all the constant terms to the right hand side, and we get 10x minus 28x minus 35x square, and we have 15x plus 15x minus 7x plus 35x square is equal to 3 minus 8. 3 minus 8. Okay. Now on the LHS we see minus 35x square and 35x square cancels out, and if you add up the like terms, that is 10x minus 28x plus 15x minus 7x, it becomes 10x minus 7x is 3x, 3x plus 15x is 18x, and minus 28x plus 18x is minus 10x, equals to 3 minus 8 is minus 5. Hence x becomes equals to minus 5 divided by minus 10. This is equal to half. Okay, so this brings to an end in solving some selected problems from exercise 8a based on all the concepts that we have discussed in this video. So this video was about so I discussed what is a polynomial, what is a linear polynomial, what is a linear polynomial in one variable, and what is an equation in general, and then what is a linear equation in one variable, which is what this whole chapter is about. We have to solve linear equations in one variable, and then we discussed about some forms of equation, that is simple linear equations, that is linear equations in simple form, where either the one side is having a variable and the other side is having constant, or both the sides are having variable as well as constants. Then we discussed about linear equations reducible to simple form, that is any equation in the linear form but having a rational terms. It can be by manipulating, that is by multiplying by some constant number both sides, it can be reduced to simple form. Then we discussed equations reducible to linear form. So equations which are not in linear form, by doing cross multiplication, it can be reduced to a linear form. And then we discussed about the rules to solve linear equations, that is we can add, subtract the same number from both sides of the equation. We can multiply and divide by the same non-zero number to both sides of the equation. We can do cross multiplication, we can apply cross multiplication, and then we can transpose terms from either side to, from one side to the other side with a change in its sign. And then finally we solved some selected problems from the exercise 8A from the textbook of author RS Aggarwal. I hope this video was beneficial. If it is so, then please like it, share it with your friends, and also once again please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. So this video was, the part 1 video was about just a preview of what you have already learned in your previous class. In the next part, part 2, I will discuss about, rather solve, how we apply solving linear equations to solve real world problems. That is basically what problems on linear equations, or applications of solving linear equations. And then also we will solve the problems from exercise 7B. So please stay tuned for the upcoming videos. Thanks for watching, and until the next video, take care and bye.